Okay, so today we are going to talk about how we can do the reverse of what we did in the first half of this lesson. So in the first half of this lesson, we started with the polynomial and we factored it in order to find its zeros. In this part of the lesson, we are going to start with the zeros and work backward to find the polynomial itself. So on page 272, in the math tip box, it says the following. If a is a zero of the polynomial, then x minus a is a factor of the polynomial. This should seem familiar because this is kind of what we talked about when we did synthetic division. So when it would tell you with synthetic division, to divide by x plus 3, that was the factor, and what we would put in the box was negative 3. It's the same idea here, except in reverse. So what we're really doing is we are saying, okay, if zeros are 0, 5, and negative 7, then that means that x equals 0, x equals 5, and x equals negative 7 are solutions. So what we do to get it in factor form like this, and this will be our first step, is to get it into an equation where it's equal to 0 instead of equal to a number. So this one's already done, x equals 0. To get this equal to 0, I would need to move the 5, so I would start out by subtracting 5 on both sides. So x minus 5 equals 0. Here, I would add the 7, and so x plus 7 equals 0. So this is always going to be our first step, because what I've done now is I've gone from a list of zeros to a list of factors. The factors are what's on the left side, so x, x minus 5, and x plus 7. Now, the first part of what they give you, n equals 3, is given to you so that you know the degree. So there should be 3 factors if the degree is 3, which there are. So x, x minus 5, x plus 7. Once you've determined all of the factors, the next thing that we do is we simply take them and we're going to write it in factored form. So our polynomial here would be f of x equals, and factored form means you multiply the factors, so x times x minus 5 times x plus 7. Our final step then is to multiply it all out, because what it wants is a standard form polynomial. So since this is a plain x, I would probably start with it and distribute it here. So that's going to give me x squared minus 5x, and then I still have the x plus 7. Both of these are binomials, which means that in order to multiply them together, I can FOIL. So f for firsts, x squared times x is x cubed. Then outsides would give me 7x squared. Insides give me negative 5x squared. And my lasts, negative 5x times 7, gives me negative 35x. And then last thing to do is to combine like terms, which are these two. So that gives me x cubed plus 2x squared minus 35x, and that is my answer. So I have worked backwards. I started with the zeros. Now I have the original polynomial. All right, so what I would like you to do is to look at this list of zeros and write down for me the next step. So write your x equals step. You can pause the video for just 30 seconds, a minute, however long it takes you to do that, but write out the x equals step and then unpause to come back and check. All right, so we should have x equals 1, x equals -1, x equals 5, and x equals -5. Next step is to get it so they're all equal to 0. So again, you need to be able to do this yourself, not just watch me do it. So I want you, yourself, pause the video and go ahead and get each of these little baby equations equal to 0. All right, and you can see how I worked that out. And so now my little equations are x minus 1 equals 0, x plus 1 equals 0, x minus 5 equals 0, and x plus 5 equals 0. So when I have those, now that tells me that what my factors are, because my factors are what's on the left side. So once I have my factors, I write out my polynomial in factored form. So x minus 1 times x plus 1 times x minus 5 times x plus 5. Now I need to multiply these all together. And when I'm looking at this one, this brings up one tip that is true. And that is that when you have factors where the only difference is the sign, that's a sum and difference pattern. And when you have those, you should always, always, always multiply those with each other, because on a sum and difference pattern, the inside and outside terms are going to cancel each other out. So see, this is -1x and this is +1x. So then that means really all I have in the answer is the firsts and the lasts. So when I FOIL that out, that gives me x squared minus 1. Same thing's true over here because the -5x and the +5x cancel. So I have x times x, which is x squared, and -5 times 5, which is -25. And then the next thing I'm going to do, again, is to FOIL those with each other. So x squared times x squared is x to the 4th. Outsides give me -25x squared. Insides are -x squared. And my lasts are +25. And so I end up with f of x equals x to the 4th. Sorry, that's a bad looking x to the 4th. It's not a 9, but I can't erase on this. So x to the 4th, try to go over it to make it look better. There we go. Minus 26x squared plus 25 would be our answer here. All right, so those are the most basic type of this concept that we could see. Now we're going to look at some ones that are a little bit more difficult. So if you want to turn the page over to 273, we are, the first one is not actually exactly one of the problems in the book. I'm changing it a little bit because the book doesn't give you an example of everything, and I'd like for you to have an example of everything. So in the My Notes margin on page 273, I want you to go ahead and write out this extra example. So same idea where they're giving you the degree and the zeros. This time we're going to have, excuse me, x equals, sorry, not x equals, n equals 5 with zeros of negative 1/2, then with 2 as a double root, and 3i. Okay, so the main procedure is still going to be the same. So we're going to start out with writing the x equals, and on some of the ones that they give you in the book and in your homework, the x equals part is already done for you. So x equals negative 1/2. It says 2 is a double root, which means it appears twice. So we're going to write it out twice. X equals 2, x equals 2. Then x equals 3i. Here is something that is super, super important. So write this down, highlight it, underline it, an asterisk by it, whatever you do for things that are important. And that is the idea that imaginary zeros always, no exceptions, always come in pairs. So they listed 3i as a 0, but if 3i is a 0, then we know for sure that x equals negative 3i is a 0 also, because it's the conjugate pair. Because when we're solving with imaginaries, they come from having square roots, so there's that plus or minus in there. So if you change the sign in front of the imaginary, that's the pair that goes with it. Okay, so now it should make sense because it said n equals 5, and now I have 5 actual zeros to work with. So when I go from here, now I need to do the equals 0 part. So these 4 over here are just pretty standard. Here I would subtract the 2, subtract the 2, subtract the 3i, add the 3i, and those are exactly what you would expect. X minus 2 equals 0 for both of these. X minus 3i equals 0, and x plus 3i equals 0. This one is a little bit different because when you have a fraction, you can't just add the fraction over. If you do that, then your polynomial doesn't have integer coefficients. So whenever you have a fraction as your 0, the first thing we have to do is we have to do bottoms up. So whatever the denominator is, in this case it's a 2, you bottoms up in front of the x. So 2x equals negative 1. And then you move the 1 over. So 2x plus 1 equals 0 is the way we would write the factor for x equals negative 1/2. Okay, now I've got all of my factors. So I write my polynomial out in factored form. So f of x equals 2x plus 1 times x minus 2 times x minus 2 times x minus 3i times x plus 3i. Now, remember that multiplication is commutative and associative, which means that the order that you multiply is not important. So what I would probably do here is choose to multiply the x minus 2's with each other instead of doing the 2x minus 1 times this guy. You should always, always multiply the imaginary pairs with each other. So I definitely am going to want to do the x minus 3i times the x plus 3i. But I'm going to start with these guys. So x squared, my insides and outsides are both negative 2x. So that gives me x squared minus 4x. And then I've got my plus 4. So those are multiplied. I'm going to bring down my 2x plus 1. And then over here, I've got x squared. This is a sum and difference pattern, so the negative 3ix and the positive 3ix cancel. So I've got x squared, and then I've got minus 9I squared. Remember, I squared is the same as negative 1. So negative I squared is really negative 9 times negative 1, which is positive 9. All right, so again, order that you multiply doesn't matter. So what I would probably do next is FOIL the 2x plus 1 with the x squared plus 9. So firsts would give me 2x cubed, outsides 2x times 9, so plus 18, oops, forgot the 1, plus 18x. Insides would be 1 times x squared, which is x squared. And my lasts, 1 times 9, would be 9. So I still haven't done anything else with this trinomial. This one's not in standard form, so in my next step, I'm going to write it out in standard form. I now need to multiply a 4-time polynomial times a 3-time polynomial. So when I do that, I'm going to have to use the box because those are pretty big as far as just trying to list it out in a line. So I'm going to rewrite this so that it's in standard form. So 2x cubed, x squared, 18x, and 9. And then over here, I've got my x squared, my negative 4x, and my 9. Or no, sorry, 4. Looking in the wrong place. Okay, you should hopefully be proficient at box multiplying because we've done a lot of it. So take a minute to multiply all this out. And then, pause the video while you're doing that, and then come back to check your answer. Okay, so this is what you should have in your box. So then for our final answer, we'll combine the like terms and write it in standard form. So I end up with f of x equals 2x to the 5th. My x to the 4th terms are all here on the diagonal, so that gives me negative 7x to the 4th. Then my cubics, 8 and negative 4 is positive 4. Then with 18 is 22x cubed. For my x squared terms, I've got 4 and negative 72, which is negative 68. Plus 9 is negative 59. Then 72x minus 36x is 36x, and then plus 36. So this is our final answer there. Okay, so very last one that we're going to do is one from the book. So this is Try These C Part B on page 273. And this one says n equals 4, so that means it'll be shorter than this one, because the smaller the degree, the general less time it takes. So we have x equals 3, x equals negative 3, and x equals 1 plus 2i. All right, so we've already got it in the x equals step. That's how it was given to us. So the next step is to write it in factor step. So subtract 3 here, add 3 there. Here it has to be done in 2 steps. I subtract the 1 and subtract the 2i. And so then what I end up with is x minus 3 equals 0, x plus 3 equals 0, and x minus 1 minus 2i equals 0. Now remember what we wrote over here. Imaginary zeros always come in pairs, which we shouldn't forget that because it says n is 4. So we have to have 4 factors. Right now I've only listed 3. The missing factor is the one that has the opposite sign as this one. So instead of x equals 1 plus 2i, the one we're missing is x equals 1 minus 2i. So I take that and I do the same thing I already did with these 3. I subtract the 1 and add the 2i so that it's equal to 0. So that'd be x minus 1 plus 2i equals 0. All right, so I'm going to start out with foiling. I guess I can't FOIL first. First I have to write it out. F of x equals x minus 3 times x plus 3 times x minus 1 minus 2i times x minus 1 plus 2i. All right, so I'm going to FOIL the two binomials together. It is a sum and difference pattern, which means that I am going to get those insides and outsides to drop out. So really all I need are the firsts and lasts. So x squared minus 9 is what I get when I FOIL that. Now these guys, there is a shortcut for this. I do want to make clear because sometimes people have trouble understanding the shortcut. If the shortcut just completely blows your mind, I want to tell you that it would be perfectly fine to make a 3 by 3 box here to multiply these two together. So if you watch me do this shortcut and you're like, I cannot do that, it's just too confusing, that's okay. Make a box instead. Plenty of people have to do that. So the shortcut uses what we did in class yesterday, where we used a binomial to treat it as a single term. So we put little brackets around the x minus 1s, and we treat them as if it were just an x, as if it was one term. Because what that allows us to do is then that allows us to see each of these parentheses as a binomial instead of a trinomial, which means that I could then FOIL these, which is helpful because this is a minus 2i and this is a plus 2i. So this is also a sum and difference pattern, meaning that when I multiply this times this and this times this, all those terms are going to cancel out because this had a positive and this had a negative of the exact same thing. So all I really need to do to multiply these two parentheses together is the firsts and the lasts. So the firsts is x minus 1 times x minus 1, which is x minus 1 squared. We can multiply that out in a second. And then for the lasts, I have negative 2i times positive 2i, which is negative 4i squared. Don't forget the squared, it makes a huge difference. When I go to simplify what's in the brackets here, so I'm just going to bring down the x squared minus 9. I FOIL out the x minus 1 squared, so that's x minus 1 times x minus 1, which is x squared minus 2x plus 1. The negative 4i squared, because I squared is really negative 1. Negative 4 times negative 1 is positive 4. And so I end up with x squared minus 2x plus 5. Now this looks totally doable. I can make a small box here with my x squared minus 9 over on this side. And so then multiply that out. And then, of course, when I'm done multiplying it out, I will combine any like terms. Now, because we were missing a linear term here, The like terms would not be on the diagonal this time. So x to the fourth is the highest power. After that would come x cubed. This one's not an x cubed, that's an x squared. Here's an x cubed, and it's the only one. So I'm going to bring it down. So minus 2x cubed. I do have two x squared terms here. That gives me a total of negative 4x squared. Then my linear term is the only one, so plus 18x, and my constant's also the only one. And so this becomes my answer. Again, I showed you the shortcut way that is the least amount of work, but if that was hard for you to understand, then instead of doing what I did here, you can just do a box to multiply x minus 1 minus 2i times x minus 1 plus 2i. You should, if you do it correctly, get the exact same answer. All right, so we've done lots and lots of examples in order to hopefully make your second part of the homework pretty easy to do. The first part is just a review from yesterday. So the ones where you have the polynomial and you have to factor it to find the zeros. All right, so that's it for 17.2.